Welcome to Huberman Lab Essentials, where we revisit past episodes for the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. This podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. Today, we're going to talk about the science of tools for fat loss. Today's episode is mainly going to be focused on how the nervous system, neurons, and some of the cells they collaborate with, like glia and macrophages, how those encourage or can encourage accelerated fat loss, because it turns out they can. Remember, your nervous system, which includes your brain and your spinal cord and all the connections that they make with the organs of the body, governs everything. The nervous system and the role of the brain and other neurons has been vastly overlooked in the discussion about losing fat. Now, I would be remiss, and I'd probably come under a pretty considerable attack if I didn't just acknowledge up front a core truth of metabolic science and also of neuroscience, frankly, which is that calories in versus calories out, meaning how many calories you ingest versus how many calories you burn, is the fundamental and most important formula in this business of fat loss and weight management in general. There's simply no way around the fact that if you ingest far more calories than you burn, you're likely to gain weight. And a good portion of that weight is likely to be adipose tissue, fat. It's also true that if you ingest fewer calories than you burn, that you will lose weight, and that a significant portion of that will come from body fat. What portion depends on a number of factors, but that simple formula is important. So a calorie is a calorie as a unit of energy, and we need to accept and acknowledge this calories in, meaning calories ingested versus calories burned formula, but the calories burned portion is strongly influenced by a number of things that you can control that can greatly accelerate or increase the amount of adipose tissue or the proportion of adipose tissue that you burn in response to exercise and food. Today, we're going to talk about the fact that your body fat of various kinds, and there are several kinds of body fat, are actually innervated by neurons. Neurons connect to your body fat and can change the probability that that body fat will be burned or not. So your nervous system is the master controller of this process, and it plays a strong role in the calories out, the calories burned component. So let's talk about fat utilization. Let's talk about how fat is converted into energy, which is sometimes also called fat burning. There's two parts to this process. One is fat mobilization, and the second is fat oxidation or utilization. And that's a process called lipolysis. Fat cells can be visceral around our viscera, our organs, or they can be subcutaneous under our skin. Stored fat has two parts that are relevant here. It's got the fatty acid part, and that's the part that your body can use. And that's attached to something called glycerol, and they're linked by a backbone. To mobilize fat, you got to break the backbone between glycerol and these fatty acids, okay? That's accomplished by an enzyme called lipase, but you can forget all that if you want. Remember, we're just trying to mobilize fat. So the first step is to get those fatty acids moving around in the bloodstream, to get them out of those fat cells. And then they can travel and be used for energy. They're going to go into cells that can use them for energy. And once they are inside those cells, they're still not burned up. You need to oxidize them. They need to be moved into the mitochondria. And then they can be converted into ATP, into energy. So just to really zoom out again to make sure I don't lose anybody, you got to mobilize the fat, then you have to oxidize the fat. And many of the things that the nervous system can do is to increase the mobilization of fat, but also the oxidation of fat. So what are these neurons that connect to fat doing? What are they releasing exactly? How do they actually increase fat mobilization, and how do they increase fat oxidation, burning of fat? Well, there are a couple of things that they release that encourage that process. And the main one that you need to know about is epinephrine or adrenaline. the conversion of these fatty acids into ATP in the mitochondria of cells is favored by adrenaline. Okay? And adrenaline is released from two sources. Adrenaline is released from the adrenal glands, which sit atop our kidneys in our lower back. And it's also released from the so-called sympathetic nervous system, although that name is a bit of a misnomer because it has nothing to do with sympathy. It has to do with stimulating alertness and promoting action of the body. It was thought for a long time that adrenaline swimming around in your body of when you're fasted, because fasting can increase adrenaline, or when you're engaging in intense exercise, or when you're stressed, is going to promote fat oxidation. That's actually not the case. The adrenaline that stimulates fat oxidation, the burning of fat, is coming from neurons that actually connect to the fat. It's a local process. And this is very important because it means that what you do, the specific patterns of movements, and the specific environment you create that can stimulate these particular neurons to activate fat, meaning to release fat, to mobilize it, and then to burn it, is going to be a powerful lever that you can use in order to increase fat loss. Okay, so let's talk about how to activate the nervous system in ways that it promotes more liberation, movement, mobilization of fat, and more oxidation of fat. So one of the most powerful ways to stimulate epinephrine, which is also called adrenaline, from these neurons is through movement. The type of movement that I'm referring to is extremely subtle. Shivering is a strong stimulus for the release of adrenaline, epinephrine, into fat and the increase in fat oxidation and mobilization. And there are other subtle forms of movement that can greatly increase fat metabolism and fat loss. There was a group in England during the 1960s and 70s that discovered a pathway by which subtle forms of movement can greatly increase fat loss. This is the work of Rothwell and Stock. It's very famous in the thermogenesis literature. And I learned about this early on when I was an undergraduate. And I asked, how did they come across this? And here's how the story goes. They were aware that some people overeat and yet don't put on weight. Other people overeat even just a little bit, and they seem to accumulate extra adipose tissue. Now, this is long before all the discussions about microbiome and hormone factors, and is long before many of the hormone factors besides insulin had even been discovered. What they did was they examined people who overate and did not gain weight. And what they observed was that those people engaged in lots of subtle movement throughout the day. In other words, they were fidgeters. And that's what they called them. And in 2015, and again in 2017, there have been studies that have explored this using some modern metabolic tracking. And indeed, simply moving a lot, being a fidgeter, bouncing your knee, standing up and pacing several times or many times throughout the day led to considerable amounts of fat loss and weight loss when people were ingesting the same amount of food. If they overate, they were able to compensate and burn off that food. So for people that are overweight who are kind of averse to exercise, fidgeting might actually be a good entry point. Now, that's great, and you can think about the protocols, but I want to nest that protocol in what I said before, which is that fat is controlled by these neurons and the epinephrine they release. Those subtle movements of our core musculature, not just the core, but all our limbs and our musculature, those low-level movements, they trigger epinephrine release from these neurons, and they stimulate the mobilization of fat. And then that fat is oxidized at higher rates. So what's the protocol? Fidget. If you're really interested in burning calories and you already exercise, you want to burn more, or you don't have the opportunity to exercise, or you're averse to exercise for whatever reason, fidgeting movements, staccato movements, standing up, walking around, pacing, all the sort of nervous activities that we're so critical of in other people and sometimes in ourselves are actually mobilizing and oxidizing a lot of fat and a lot of energy. And while this probably won't compensate for chronic overeating. The caloric burn from this is considerable and very likely can offset a meal that had excessive calories or a kind of steady state of eating too much. Now it should make sense why shivering is one of the strongest stimuli that one can incorporate to stimulate fat loss. Now, shivering is almost always associated with cold. We think shivering, we think cold, because when we get cold, we shiver. And there are two ways that shivering can increase fat loss. And there are several ways that you can use shivering, you can leverage shivering, and you can leverage cold to accelerate fat loss. But you have to do it correctly. And most of the people that are using cold and, frankly, suggesting cold as a means to increase metabolism fat loss are suggesting the exact wrong protocol. Most people out there are using cold exposure, typically by taking cold showers or by getting into cold water of some other kind, a lake or a river or a cold bath or an ice bath. Since today we're talking about accelerating fat loss through the use of science-based tools, I want to emphasize a study that was published in Nature just a couple of years ago showing exactly how cold increases metabolism and fat loss. Okay, so we have several kinds of fat, 3 kinds in fact. We have white fat, white adipose tissue, and we have brown fat or brown adipose tissue. And there's a third kind, which is beige adipose tissue. White fat is the type that we traditionally think of as fat, subcutaneous fat. And it is not particularly rich in mitochondria. It is there as an energy storage site. And we have to mobilize the fat out, as we talked about before, and burn it up elsewhere. Brown fat largely exists between our shoulder blades and on the back of our neck, between the scapulae. And it's rich with mitochondria, which is why it's called brown fat. And brown fat has a particular biochemical cascade whereby it can take food energy and it can take food basically, break it down, and convert it into energy within those cells. But unlike fatty acids from white fat, which have to travel elsewhere, get broken down in mitochondria and converted into ATP, etc., used by the mitochondria rather, brown fat is thermogenic. It can actually use energy directly. Cold causes the release of adrenaline from your adrenals, and it causes the release of epinephrine from these neurons that connect to fat. The paper published in Nature shows that it is shivering itself that causes the brown fat to increase your burning, your burn rate, and your metabolism. And it works like this. When you get into cold and you shiver, the shivering, that low-level movement of the muscle, those small movements, triggers the release of a molecule called succinate, succinate, succinate. And succinate acts on the brown fat to increase brown fat thermogenesis and fat burning overall. The question then is how long to get into that cold environment, and how cold should that environment be? So first, let's talk about how long to get into that cold environment. It turns out that if you want to trigger the shiver, what you want to do is to get into the cold and then get out of the cold, and typically not dry off, and then get back into the cold and out of the cold. That will definitely stimulate more shivering than just getting into the cold itself. So how cold should it be? And look, if you get into water that's very, very cold, it can actually shock your heart. It can actually give you a heart attack if it's truly, truly ice cold and you're not adapted to that. So proceed with caution, please. I'm not a physician and I don't want to see anyone get hurt. Cold, just cold enough to be uncomfortable is a good place to start. So for some of you, that's going to be 60 degrees. For some of you, that's going to be 55 degrees. For some of you, it's going to be high 30s, right? Depends on how cold adapted you are. So what you need to do is find a temperature that you can get into 1 to 5, probably 1 to 3 times a week if you really want this to accelerate fat loss. And you want to get in until you just start to shiver, and then you want to get out and not dry off. Wait anywhere from 1 to 3 minutes and then get back into the cold. So here's a potential kind of sets reps protocol that you can play with. Find a temperature that induces shiver for you. That's going to vary depending on your cold tolerance and how cold adapted you are. 1 to 3, maybe 5 times a week. Get in until you, or get under the shower or whatever it is, until you start to shiver, genuinely shiver. Then, after about a minute or so, get out. Spend 1 to 3 minutes out, but don't dry off. Get back in for anywhere from 1 to 3 minutes, but try and access the shiver point again. And you might do 3 repetitions of that. So it's 3 times in and 3 times out total. Next, I'd like to move to exercise and how particular timing and types of exercise can vastly improve fat loss. The topic of exercise is a kind of controversial one. I think the most simple way, the most fluid way to have this conversation about exercise and fat loss is in terms of 3 general types of training. And those are high-intensity interval training, so-called HIIT, H-I-I-T, so high-intensity interval training, sprint interval training, so that's going to be very high intensity, or SIT, or moderate intensity continuous training, MICT. So we've got HIIT, SIT, and MICT. If you'd like to map this to VO2 max, SIT, this sprint interval training, was defined as all out, greater than 100% of VO2 max bursts of activity that last 8 to 30 seconds, interspersed with less intense recovery periods. So this would be sprinting downfield for 8 to 30 seconds, then maybe walking back for about a minute or 2, and then sprinting again and then continuing. So that would be SIT. HIIT, H-I-I-T, is defined as submaximal, so 80 to 100% of VO2 max, bursts of activity that last 60 to 240 seconds, interspersed with less intense recovery periods. MICT, okay, this moderate intensity continuous training is steady state cardio, sometimes called zone 2 cardio these days on the internet, which is performed continuously for 20 to 60 minutes at moderate intensity of 40 to 60% of VO2 max, or if you prefer heart rate, 55 to 70% of max heart rate. Okay, so we can think about high, medium, and low intensity exercise, although low intensity usually means that you could carry on a conversation, or maybe you'd have to gasp every few steps or so while trying to talk and run. That's, I think, going to be the most useful way to have this conversation that we're having now, because there's so many different forms of exercise that people do, and intensity is important. Let's ask the question that I think many people are wondering about, which is it better, meaning do you burn more fat if you do your exercise fasted? And fasted in this respect could be that you wake up in the morning, you've been fasting all night, you just hydrate, and you exercise. For short periods of training, it doesn't really seem to matter whether or not you eat before training or you don't, if your goal is fat oxidation. At a period of about 90 minutes of moderate intensity exercise, there's a switchover point whereby if you ate before the exercise, you will burn far less fat from the 90-minute point onward than you would if you had gone into the training fasted. Now, there are also studies that point to the fact that you don't have to wait to 90 minutes in order to get this enhanced fat burning effect. If one does high-intensity training, or even the very high-intensity forms of training like sprints or squats or deadlifts or any kind of activity that can't be maintained for more than these, 8 or I would say up to 60 seconds, so a set of lifting weights repeated, if that's done for anywhere from 20 minutes, so weight training or powerlifting or these kinds of things, or kettlebell swings, or up to 60 minutes, well, then the switchover point in which you can burn more fat if you go into that fasted comes earlier. And this makes sense because there's nothing holy about the 90-minute point for medium intensity zone 2 cardio. That 90-minute point is the point in which the body shifts over from mainly burning glycogen, basically sugar that comes from muscles or the liver, and realizes this is going on for a while. I'm going to shift over to a storage site fuel that is in reserve, like body fat. This is something that has to do with the milieu of various hormones. what has to happen is insulin has to go down far enough. So if you ate before the exercise, you'd have an increase in insulin. If you ate carbohydrates, you'd have a bigger increase in insulin. Fat and proteins indeed will have lower amounts of insulin, and fasting will give you the lowest amount of insulin. Well, then that switchover point is going to come earlier in the exercise. And if you think about it, if you were to do something high intensity for 20, 30, 40 minutes, so maybe lift weights and then get into zone 2 cardio, if you were fasted, the literature says that you're going to burn more body fat per unit time than if you had eaten before or during the exercise. So what does this mean? This means if you want to burn more body fat, if it's in your protocols and have been approved to do this safely, exercise intensely for 20 to 60 minutes. The higher the intensity, obviously, the shorter that bout is going to be, and then move over into zone 2 cardio. And if you do that fasted, then indeed you will burn a higher percentage of body fat. But if you can't even get to the exercise, if you're somebody who just can't do the training at all, you're unwilling to, or you're incapable of training unless you eat something, then obviously eating something makes the most sense. And what you eat prior to exercise, that's a whole other biz that people argue about and fight about, whether or not you should go into it with low carbohydrates or higher carbohydrates, all of that. But in general, the theme there is very simple, which is that you want insulin levels to be pretty low if your goal is body fat reduction. This could be distilled into a simple protocol whereby 3 or 4 times a week you do high intensity training followed by either nothing or followed by low intensity training, especially if you're able to do that fasted. And I should just mention that none of this stuff about fasted is about performance. If you want to perform really well, this is for reasons of performance, and you want to, it's for a sport or a competition, it's not for body fat purposes. Well, then all of this kind of falls away and is modified by what's ideal to eat for performance. But what we're talking about today is how to optimize body fat loss. So I think you get the principle now. But you should all be asking yourselves, as scientists of yourselves, why would it be that certain patterns of exercise would lead to more or less fat loss? And again, it has to do with the neurons. It has to do with how we engage the nervous system. So while non-exercise activity-induced thermogenesis, NEAT, the fidgeting, and cold can induce thermogenesis by engaging shiver-type movement or low-level movements, big movements that are of very high intensity, meaning they require a lot of effort, deploy a lot of adrenaline, epinephrine from our neurons, and signal particular types and amounts of fat thermogenesis, fat oxidation. Whereas low-level intensity exercise, low or moderate intensity exercise, walking, running, biking, where you can do that easily, there's not very much adrenaline release. So adrenaline, and aka epinephrine, is really the final common path by which movement of any kind, whether or not it's low-level shiver or whether or not it's lifting a barbell, sprinting up a hill, or doing a long bike ride, adrenaline is the effector of fat loss. It's the trigger and it's the effector. So now I want to turn our attention to compounds that increase epinephrine and adrenaline, as well as compounds that work outside the adrenaline epinephrine pathway to increase the rates of fat loss. I almost always save compounds and supplements and things of that sort to the end, because I do believe that people should look first toward behavioral tools and an understanding of the science before they look toward a supplement or a particular thing that they can extract from diet. This is mainly to try and shift people away from the kind of magic pill phenomenon, or the idea that there is a magic pill, because there really isn't, and frankly, there never will be. But there are some compounds that can greatly increase fat oxidation and mobilization, and understanding which compounds increase oxidation or mobilization can be very useful if your goal is to accelerate fat loss. There are things that people can ingest that will allow them to oxidize more fat, and that occurs mainly by increasing the amount of epinephrine that is released from neurons that innervate fat tissue. One of the more common ones is one that you may already be using, which is caffeine. It's well established that caffeine can enhance performance if you're caffeine adapted. Now, caffeine for burning more fat, for oxidizing and mobilizing more fat, is an interesting one. It can be effective at dosages up to 400 milligrams. 400 milligrams is roughly a cup and a half of coffee or 2 cups of coffee. Nowadays, there's a lot more caffeine in coffee. So if you go to a typical cafe and you were to get their medium size, that would have close to 1 gram of caffeine, which is why if you're a regular caffeine consumer and you don't get that gram of caffeine in your coffee each day, you will get a headache. It can cause constriction and dilation of blood vessels in ways that's complicated, but you'll get a headache. Caffeine can enhance the amount of fat that you burn in any duration of exercise, and it can shift the percentage of fat that you oxidize compared to glycogen, unless you take that caffeine and it ramps you up so much that you're training really, really intensely. The bottom line is, if you like caffeine and you can use it safely, ingesting somewhere between 100 and 400 milligrams of caffeine prior to exercise, somewhere between 30 to 40 minutes before exercise, can be beneficial if we're talking about fat oxidation, burning more body fat. And if caffeine is the kind of the entry point for most people of using compounds to increase the rate or percentage of fat loss in exercise and even at rest, what are some of the other things that are useful and interesting? Well, in terms of tools that are actionable and have reasonable safety margins, I've talked before about something called GLP-1. This is something that can be triggered by the ingestion of yerba mate. Mate increases GLP-1. GLP-1 is in the glucagon pathway. So let's just quickly return to our biochemistry. As you recall, fat is mobilized from body fat stores, and then it's burned up, it's oxidized in cells. It actually needs to be converted into ATP, and those fatty acids are essentially converted into ATP in the mitochondria of the cell. High insulin prevents that from happening, and glucagon facilitates that process. Glucagon facilitates that process through increases in GLP-1. The short takeaway is mate increases GLP-1 and, yes, increases the percentage of fat that you'll burn. It increases fat burning. And that is especially true, it turns out, from the scientific literature, if you ingest mate prior to exercise of any kind. So if you want to burn more fat, drinking mate before exercise is good. Drinking it at rest when you're not exercising will also help shift your metabolism toward enhanced burning of fat by increasing fat oxidation. Now, there's a whole category of pharmaceuticals that's being developed right now that are in late-stage trials or are in use for the treatment of diabetes, which capitalize on this GLP-1 pathway. They go by various names, and there are people on the internet who are selling these things. They are prescription drugs, and I want to emphasize that they are prescription drugs, and you obviously wouldn't want to use any of these without a prescription and a requirement. It does seem that they are effective for the treatment of certain kinds of diabetes and lead to fairly significant weight loss and reduction in appetite. So this is kind of the modern version of GLP-1 is pharmaceuticals of GLP-1 metabolism are drugs such as I can never pronounce this. I can't seem to pronounce many things, it seems. Semaglutide is the way I would pronounce it. In any case, this compound increases GLP-1. It's actually a GLP-1 analog in some cases, and they go by various types of trade names. And again, the semaglutide is the prescription version it's kind of the heavy artillery GLP-1 stimulant, and again should be only explored with a prescription. So those are the compounds that really increase fat oxidation directly. There are going to be a number of things that impact insulin and glucagon that are going to shift the body toward more fat burning. And so, for instance, berberine, which comes from a plant, or metformin are compounds that are now in kind of growing use for reducing blood glucose. They are very potent at reducing blood glucose, which will reduce insulin, because the job of the hormone insulin is to essentially manage glucose in the bloodstream. So there are a huge gallery of compounds that will reduce insulin and thereby can increase fat oxidation. And that's because, as I mentioned before, fat oxidation, this conversion of fatty acids into ATP in the mitochondria, is inhibited by insulin. So if you keep insulin low, you're going to increase that process. which brings us full circle back to the issue of diet and nutrition. There is really solid evidence from the Gardner lab at Stanford and from other labs showing that when you look at different diets, you look at low-fat diets, high-fat diets, keto diets, intermittent fasting, provided people stick to their particular diet, it doesn't really matter which diet you follow. You can still get a caloric deficit and you get weight loss. Adherence, however, is always an issue. And so what I always say is that you want to use the eating plan that is obviously beneficial to your health, but the one that allows you to adhere to whatever it is that the particular nutrition protocol is, right? If you can't stick with something, then it's not very worthwhile. But from the purely scientific standpoint, there's also an advantage to keeping insulin low. Now, that doesn't necessarily mean you go to zero carbohydrate. I've talked before about my preferred way of eating is to go low or no carbohydrate throughout the day for alertness, to get that adrenaline release and the focus that goes with it, et cetera, and the ability and to think and move and do all the things I need to do during the day. And then I eat carbohydrates at night because it facilitates the transition to sleep. That's what works for me. But when insulin is low, you do place your system in a position to oxidize more fat. And so that's why I think a lot of people do see benefit from lower carbohydrate or moderate carbohydrate diets, because when insulin is low, you are in a position to oxidize more fat, both from exercise and at rest. So once again, we've covered an enormous amount of material. We've talked about the science of fat loss. And in particular, we've explored this topic from the perspective of the nervous system, how neurons, and in particular, the release of things like adrenaline, epinephrine, can facilitate fat mobilization and oxidation. We talked about NEAT, fidgeting, this non-exercise type movement that can greatly increase caloric burn and why that is. We talked about shiver, another form of non-exercise movement that can really increase both caloric expenditure due to the shiver, due to the movement, as well as increase thermogenesis, the heating up of the body through things like brown fat, and even the conversion of white fat to brown fat, which is a good thing if you want to oxidize fat. We talked about cold as a particular stimulus to induce shiver and how to use getting into and out of cold as a way to stimulate shiver and avoid cold adaptation so that you continue to oxidize and burn fat, if that's your goal. Talked about exercise, how rather than thinking about cardiovascular or weight training exercise, that we should perhaps look through the lens of this adrenaline system and how it interacts with fat stores and think about low, medium, or high intensity exercise, whether or not we show up to that fasted or not. Turns out showing up to that fasted can be useful if you start with high intensity movements and then move into lower intensity type exercise. If you're going to go long duration, it probably doesn't matter unless you're exercising longer than 90 minutes, whether or not you eat or not. We talked about caffeine as a stimulant and a stimulus for epinephrine and adrenaline release as a way to access more fat metabolism. And last but not least, I want to thank you for your time and attention today, and thank you for your interest in science.